We've talked about Io before, Jupiter's weirdest moon. It has hundreds of active volcanoes that regularly spew molten lava hundreds of miles into space. That's not normal, even for space, but it's also not unique. We've seen similar activity on other moons and planets. But Io is different because of its big brother, Jupiter. You see, Io orbits closer to Jupiter than any other moon in the solar system. It whips around the planet every 42 hours, making it the fastest moon ever. And as it flies past Jupiter, those volcanoes send plasma from Io's surface into the planet's colossal magnetic field. There they form a giant glowing donut that funnels charged particles to Jupiter, powering the planet's most powerful storms. Welcome to my channel. Today, we are talking about Io's plasma Torus, the weird ring of plasma around Jupiter that makes the planet's magnetic field glow at night. First, though, let's talk about Io. Io is one of Jupiter's four Galilean moons. In our solar system, only our moon and Charon, Pluto's weird partner, get closer to their planets than Io gets to Jupiter. Io sits inside Jupiter's colossal magnetosphere, the biggest magnetic field in the solar system. Jupiter's magnetic field extends over 900,000 kilometers out from the planet. That's 3/4 of the distance between the Earth and the Sun. But if you want to feel the effects of Jupiter's magnetic field, you have to get close. Io orbits just 422,000 kilometers from the planet. That puts it right on the edge of Jupiter's inner radiation belt, where tens of thousands of particles smash into Io every second. These particles ionize the surface of Io, stripping electrons off atoms and molecules, turning them into plasma. That plasma rises up through Io's thin crust and spills over the moon's volcanoes, and boy, does Io have a lot of volcanoes? The whole moon is covered with them. Most are small, but some are gigantic. The tallest is probably Tvashtar, which reaches 300 meters high. Some scientists think that's tall enough to be the solar system's tallest mountain, beating Everest by almost 1 kilometer. And Io's volcanoes erupt almost constantly, spewing sulfur and oxygen into space. The eruptions themselves are relatively small. They reach only about 300 meters high, lower than the average stratovolcano on Earth. But because there's no air on Io, those lava flows can travel much farther. On Earth, lava flows rarely travel more than 50 kilometers from the volcano. But on Io, scientists think it might be able to travel all the way around the moon, which is 3,000 kilometers in circumference. In total, Io spews 300 million tons of material into space every day, including lots of sodium and potassium. That material drifts away from Jupiter along Io's orbit and collects into a huge cloud that glows an eerie green in Jupiter's night. NASA's Juno probe has been taking pictures of this cloud since arriving at Jupiter in 2016, but we knew about Io's Torus long before Juno got there. Back in 1979, NASA's Voyager 1 probe spotted the glowing cloud as it passed Jupiter. At the time, scientists had no idea what they were looking at. They didn't know that Jupiter had active volcanoes or that Io was spewing material into space. But when Voyager 2 flew by Jupiter a year later, scientists were prepared. They saw the same cloud of material and realized it must be coming from Io. By the time Galileo arrived in Jupiter orbit in 1995, scientists had figured out that it was dealing with a huge plasma cloud, a giant bubble of ionized gas floating around Jupiter. They named it the plasma Torus, but they still didn't know why it was there. It wasn't until NASA launched the Hubble Space Telescope that we got our first close look at Io's volcanoes. Scientists saw that the material leaving the volcanoes matched the composition of Jupiter's Torus. By then, it was pretty clear that the Torus was made of stuff coming off Io's volcanoes, but figuring out how it got there required a little more work. Scientists knew that something was dragging the plasma away from Io and spreading it into a giant ring, but they weren't sure what. So they installed a magnetometer on the Galileo probe that would allow it to measure Jupiter's magnetic field as it orbited the planet. And what they found surprised them. They discovered a huge hole in the planet's magnetic field just above Io's orbit. This hole acted like a giant vacuum cleaner, sucking plasma off Io and forming the torus. It turns out that Jupiter's magnetic field isn't perfectly symmetrical. The side facing Io is weaker than the opposite side, so the plasma released by Io's volcanoes is pulled toward the weaker side of the field. Once it reaches Jupiter's surface, the plasma creates powerful storms that glow eerily at night. These aren't your typical lightning storms. Typical thunderstorms produce about 100 times less power than the storms created by Io's plasma. Instead of being blown horizontally by wind, Io's plasma hits Jupiter head-on, piling up and amplifying the storm until it becomes the biggest storm in the solar system. It's so big that it covers over 30,000 kilometers of Jupiter's surface, which is more than half the distance between New York and Los Angeles. And unlike our storms, which weaken quickly after hitting land, Jupiter's storms stay strong forever. Well, maybe not forever, but certainly for years. Jupiter's storms don't dissipate because the plasma from Io keeps feeding them energy. It's a positive feedback loop. The storms pull more plasma from Io, and the plasma makes the storms stronger. You could call it a kind of perpetual motion machine, although I wouldn't expect it to power anything anytime soon. That's because these storms happen in Jupiter's atmosphere, high above the planet's clouds. Even if we could harness the power of the storms, there's no way to deliver it to Jupiter's surface. And besides, Jupiter doesn't need our help. It already has a way of using the energy from Io's torus. You see, the plasma doesn't just fuel storms. It also generates powerful electric currents inside Jupiter's atmosphere. Those currents make Jupiter the most electrically powerful planet in the solar system. It generates over 10 quadrillion watts of electricity. For scale, that's roughly the power consumption of the entire United States. Right now, scientists think that Jupiter uses most of this energy to power its magnetic field. Maintaining a magnetic field takes a lot of energy, especially a giant one like Jupiter's. So it makes sense that Jupiter would use its own plasma to fuel its own magnetic field. The rest of the energy goes into heating Jupiter's atmosphere. That's why the planet's upper atmosphere is a whopping 3,000 degrees Celsius, hot enough to melt rock and metal. Of course, while Jupiter is benefiting from Io's plasma, the moon itself is taking the worst part of the deal. Remember all that plasma getting sucked toward Jupiter? A lot of it comes from Io, but it also pulls material off the other inner moons, Europa, Ganymede, and Callisto. As the plasma stream pulls material away from these moons, it leaves behind a thin disk of dust. This dust blocks some of the sunlight reaching the moon's surfaces, cooling them off. If it weren't for the plasma torus, Europa would be 100 degrees Celsius warmer. And that would be a big deal because Europa has a massive ocean under its icy crust. If the ocean could absorb all that extra heat, it might be warm enough to support life. So far, we haven't found any signs of life on Europa, but maybe one day we will. Until then, though, we'll just have to marvel at the amazing things happening on Jupiter. Every day, the plasma torus creates new auroras, which glow different colors depending on what part of the torus they come from. The sodium and potassium from Io's volcanoes create yellow auroras. Meanwhile, the oxygen they release makes red auroras. Scientists even saw blue auroras that they think come from hydrogen sulfide. These auroras stay active 4 months, way longer than auroras on Earth. That's because they don't depend on the sun. They're powered entirely by Io's volcanoes. So next time you look up at the night sky, remember that there's a giant donut of plasma glowing around Jupiter, powering some of the most powerful storms in the universe. Maybe someday we'll figure out how to harness that power for ourselves. Until then, though, it's just another beautiful thing about our amazing universe. And thanks for watching.